As you can see in your note page that I provided to you, first thing we need to know is what standard form is, and it's y equals ax squared plus bx plus c, where a, b, and c are just real numbers. It could be a decimal, it could be a whole number. For this part of Unit 4, A, B, and C will be whole numbers. They could be positive or negative, but for this part of our unit where we are not using a calculator, they would be whole numbers. And so what it means to actually factor a quadratic is we are taking our original quadratic equation that we've been provided, and we're breaking it down into polynomial expressions that when we multiply them back together, like we did when we multiplied polynomials, we should get back to that quadratic. So you'll notice on your note page, I'm going to switch over to the document camera here. I gave you x plus 4 and x minus 1 are factors of x squared plus 3x minus 4. If we expand, which means multiply, just so you're aware, if we expand those factors or multiplying together, I'm going to do the box method just like we did in our last video. I'm going to have x plus 4 and x minus 1. X times x gives me x squared. X times 4 gives me 4x. X and negative 1 gives me negative x, and then negative 1 times 4 gives me negative 4. Combining my like terms gives me x squared plus 3x minus 4, which proves to me that they are factors of that because it gets me back to my quadratic that I was given. This means that expanding and factoring are actually the opposites, or inverses, whatever you want to call it. They are doing the opposite thing of the other. So we're actually going to work on factoring. So last video, when I talked about multiplying these polynomials or these binomials, these are both binomials, bi meaning two, because there are two terms inside of this. This would be a trinomial because there are three terms. Anything more than three terms we consider a polynomial. So I'm going to start working on using that vocabulary throughout this video for you. So I started previously with these two binomials on the outside, and I was working on finding the interior. I was working on finding the area. When I'm factoring, I'm giving you the area, I'm giving you the inside, and our goal is to find the length and the width of this rectangle we've created. And what I'm going to do is I'm going to actually use length and width as our terminology right now so that you get more comfortable with what we're actually doing. And I'm going to show you using online algebra tiles so that you can see what I'm doing. So here I have one box that represents the area of x squared. So that's going to be the first part of my box. And then I have 8 x tiles here. And what this represents is a width of 1 unit and a length of x units. So I'm going to start putting these together. And what I'm going to try to do is split this up so that, and I'm going to turn these sideways just so you see what I'm doing. I'm going to work on splitting these up so that I have 12 that go in here. So here is my plus 12, and I'm going to start lining them up with my x tiles. And again, the only reason I'm doing this is so that you have a visual of what's actually happening so that you understand how I'm creating these rectangles with area and splitting it up so that you see the same interior picture that we did when we multiplied. Now you'll notice that if I'm talking about the area creating a perfect rectangle where the length and the width multiply to make what's inside, this whole X down here doesn't have any single digit units lined up with it. So that tells me that X and 4 and X and 4 doesn't work. So I need to start moving some of these around. Well, that's not going to work because I would have to take some tiles from here. But if I take this last one and I move tiles over here, so then this would have a side length of X. I apologize for my atrocious handwriting with the mouse. This has a side length of 2 units. So this would be 2. This also has a side length of X. And here it's 1, 2, 3, 4, 5, 6. So what I'm going to do is I'm going to switch back to the document camera. And I'm going to redraw that picture in here. So if I look at the interior of this rectangle, which represents the area that I was given, this corner was always my X squared. If you go back and look at any of the multiplying that we did, this was always my biggest exponent. And here our biggest exponent is always going to be squared. So this will be X squared. My 12 single units had to go in the bottom right corner. And then my goal was to take the 8X and split it up in a way that I could evenly distribute 12 to match up lengthwise here and widthwise here. So this ended up being 6 X's and 2 X's, which gave me X plus 6 and X plus 2. Now, if you go back through and multiply all of these, the 2 binomials on the outside, you end up getting the exact same thing on the inside. So that tells me that my factors would be X plus 2 and X plus 6. Now that was a purely visual approach. And if that helps your brain right now, that's fantastic. But that's not your only option for factoring these. And once we get into more complex factoring, you're going to need a more algebraic approach, which is what I'm going to do on these next 2 examples. So we're going to do X squared plus 5X plus 6. And again, this represents the interior of our box. So our goal will be to find the exterior, or the binomials that when I multiply these together, give me X squared plus 5X plus 6. So the X squared term will always go in my top left corner. And my single digit units, my constant, will always go in the bottom right hand corner. And that goes back to how we viewed these pictures here when we did our multiplying. This always ended up being the largest X squared term. This bottom right hand corner always ended up being where our single digit units went. So now what I need to do is figure out how I'm going to split up 5X into these 2 corner boxes so that when I multiply, I get 6 from these units on the outside here that represent the side length of these two spaces. So here's how I think of it. I'm going to take the 5x, and I'm going to figure out what I could split 5x into. How do I get 5x when I add two things together? Well, I've got 5x and x. I've got 3x and 2x. I've got, 5x and nothing. I've got 4x and 1x. Well, this isn't going to work because it doesn't have two things. So, if you think about the coefficients here, because that's what I'm going to have to use, because that's going to represent this unit, this length here. Well, I'm going to have to end up multiplying the length of this box and the length of that box together to get 6. So this would be 3 times 2, and this would be 4 times 1. This gives me 4. That doesn't work. This gives me 6. So I know that those two corner boxes have to be 3x and 2x. Now when I combine 3x and 2x together, I get 5x, which is perfect because that's what we need. Now when I start looking at the length of these boxes on the inside, I'm going to start with my x squared. That would have a side length of x and x, because those two things multiplied together give me an area of x squared. In order to get 3x with this box, it has a side length of x, which means the side length of 3 is what's missing to multiply to make 3x. Similarly here, I'm missing a 2 to get 2x. So when I look at my single digit or my constant box, 3 times 2 does in fact give me 6. So my factors are x plus 2 times x plus 3. And a good way to double check and make sure you are correct is multiplying on the outside in to every box to double check that what you have here will in fact get you back to your original quadratic. I have one more that we're going to do. And the reason we're going to do this one is there is a negative. And I'm going to give you a little bit different approach here, because again, I want you to have all possibilities in your brain. So I'm still going to start with the box, and I'm going to put x squared and negative 24 where they go. So I have x squared in my top left corner, and I have negative 24 in the bottom right corner. What I'm going to do here is I'm actually going to work with negative 24 first. Now I know that when I multiply these two lengths together, they have to create negative 24. So I'm going to start listing my options. Well, I could have negative 12 times 2. I could have 12 times negative 2. I could have negative 6 times 4. I could have, 6 times negative 4. There's a lot of different options, but I'm just going to start with the first two that come to my mind. So, oh gosh, why did I put negative 6? This should be negative 2. I was jumping ahead and thinking about 6 times 4. So these are the things that multiply together to make that bottom corner that I need. But when I put these two numbers in these corners, they have to add together to make positive 10x. So this is multiplication to get 24. Now I need to think about what addition would happen to make 10 using these numbers that I know give me negative 24 when I add, or when I multiply. So now I'm thinking, okay, negative 12 plus 2 would give me negative 10. That's not going to work because I want positive 10. 12 plus negative 2 does in fact give me positive 10. So that tells me these two are the values that will be in these boxes here. Now I'm going to continue. Negative 6 times plus 4 would give me negative 2. 6 plus negative 4 would give me positive 2. So that again is just showing you that even though these two things multiply to make negative 24, if I used negative 6x and positive 4x in these corner boxes, it would give me negative 2x, which is not what I need. So I'm going to put 12x and negative 2x here. And now I need to think, what would my side lengths have been for each column and each row in order to get negative 2x and negative 24 when I multiplied with these two things along the top? If you remember doing greatest common factor, that is another thing that you can use to think about here. So if I'm looking at x squared and 12x, both of these things had to be multiplied by x in order to create both of those statements. Another way of thinking it is the greatest common factor between x squared and 12x is x. Now, in order to get x squared, this side would have to be x because x times x makes x squared. What's missing to give me negative 2x when I multiply by x? Well, this would be negative 2. What's missing here to give me 12x? That would be 12. Now, if I multiply everything, it should work. X times x gives me x squared. Negative 2 times x gives me negative 2x. X times 12 gives me 12x, and negative 2 times 12 gives me negative 24. When I combine these two together, 12x minus 2x gives me 10x. So here my factors are x plus 12 and x minus 2. It does not matter what order you write these in. It does not matter if you put 12x down here and negative 2x up here in that corner. What does matter is where these two things go first, because then you will follow along the same process that I just did in all three of those examples.